All right, you guys, we are defining rigid transformations. This is slide 14 on translations. Well, if you haven't figured it out yet, I'll say it one more time. Rotations, reflections, and translations, this being the last one, these are all rigid motions because they do not increase or decrease from the pre-image to the image in size. Dilations are not rigid transformations. That's the only one that's not a rigid transformation. Keeping this in mind, translation is when you take a figure and you shift it somewhere. Doesn't change the figure's size or shape. Therefore, it is a rigid transformation or a rigid motion. All right, well, with that in mind, let's see what's going on. So I clicked on my GeoGebra. Looks like we've got some kind of polygon. I don't see anything else going on. Let me back out. No, just a polygon. And looks like I'm probably going to shift this sucker somewhere. All right, well, let's see what I got. Question number 1. Begin by translating polygon ABCD. Create a line segment of length 5 units to the right of points A, B, C, and D. Okay, so 5 to the right on every single one. So I'm going to go segment. Ooh, segment with given length. Let's see what that does. So segment with given length, select a point, then enter a length. So I'm going to select A. And I'm going to select 5. Oh, sweet. Look at that. 5 to the right. So 5 to the right. 5 to the right. And 5 to the right. Okay. Let's see what else I got to do. All right. Connect the points you created to form a polygon that is congruent to ABCD. All right. So let me go to my segment this time. So looks like A connected to B. So E will connect to H. B connected to C, so H connects to G. C connected to D, so G connects to F. And D connects to A, so F connects to E. I got somebody at my door, you guys. Hang on a second. Let me pause this. All right, you guys. Sorry about that. All right, so let's see what else I got to do here. So I've created the points. When you're done, you will have translated polygon ABCD to the right by 5 units. Measure the slopes of the lines you created. Record the measures of the tables in the table. Okay. Okay, so I've got to find the slope of the lines. Which lines? Measure the slopes of the line segments of the construction path. Okay, that means the cross bars. Well, I'll tell you right now, all of these are horizontal lines, which means the slope is going to be automatically 0. But let me show you how to do that, my visual people. So I'll come up here to the angle icon and I select slope. And I'm going to select A to E, 0. B to H, 0. C to G is 0. And D to F is 0. So all horizontal lines have a slope of 0. All right, so let's see. That was AE, 0. That was BJ, 0. Let's see, CK. Oh, wait. No, it wasn't BJ. It was BH. BH. Messed that up. BH was 0. So A to E, B to H, C to G, C to G. 0. And last one was D to F. D to F was 0. All right. Easy breezy. Hey, slopes of zeros. All horizontal lines have a slope of 0. By the way, all vertical lines have undefined slope. So you would just put undefined or no slope. All right, so question 2. How do the slopes of the line segments in part A compare to one another? In geometric terms, what you conclude about the lines? Well, let's see. All 4 lines were horizontal and have a slope of 0. Any lines that have the same slope are parallel. We've learned that before, so I can put that in. So all 4 lines were horizontal, so their slopes were all 0. And lines with the same slope are parallel. Oh, hey, there you go. Question 3. All right, add another set of points that are 8 units below A, B, C, D. This time you'll need to rotate the lines into a different orientation. Connect the points you created to form another polygon that is congruent to A, B, C, D. When you're done, you'll have translated the polygon down by 8 units. Measure the slopes. Well, down, I just said this. How funny. So this time they're going to be vertical lines because going down means vertical, which means all of my slopes are going to be undefined, or you can put no slope. All right, so let me get out of this. This is a little busy. All right, so this time I'm going to go down. Let me move this so I have enough room to do that. All right, so this time I'm going to go down. So let's see, A, there's 1, 2, 3, 4, 5. Oh, wow, I've got to move it. Okay, 1, 2, 3, 4, 5, 6, 7. Ew, I don't like I'm having to eyeball this. I got to come in a little bit. There it is, 7. Okay. Let's see, this is kind of hard to get. All right, so back to the segment. So I'm at 2, so 1, 2, 3, 4, 5, 6, 7. Was it 7 or 8? Darn, I done forgot now. Probably 7. Was it 7? That was 8. Back up. Gotta go down by 8. All right, so let's see. So down 1, 2, 3, 4, 5, 6, 7. Oh, man. This is not helping me. I need to move it. Well, this is kind of frustrating, huh? Let's see if I can. All right, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. There's 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. All right. So it's 1, 2, 3, 4, 5, 6, 7, 8. So I'm on 3. 1, 2, 3, 4, 5, 6, 7, 8. A little off. And that's 4, 5, 6, 7, 8. Yeah, they're all vertical. So you guys can see this is just, they're all vertical. So they're all going to be no slope or undefined. All right, so I'm looking at VH, but they want slope. So if I click on slope, it's going to give it to me. What is this doing? Yeah, something's going on here. All vertical. Oh, okay, that's why it wasn't straight up vertical. Vertical lines have no slope or undefined slope. All right, so let's see. The first one was AE. The second one was BH. The third one was DF. The last one is CG. And they all are undefined. You put no slope. Okay, so they'll take undefined also. All right. Oh, my goodness. That was kind of So question 4, how do the slopes of the lines in segments in question 3 compare to one another? Well, they were all the same. They were all vertical. I guess they're also going to be parallel because they were all the same slope, even though there were no slope. Okay, so I can write this. All 4 lines are vertical, so their slopes were all undefined. They are parallel, and move the figure in the same direction, the same distance. Okay. Looks like I'm finding angle measures in question 5. It's time to verify that a translation is a rigid transformation. Begin with the angle measurements. Measure the angles of polygon ABCD and the angles of the reflected image. Record the measure of the angle to the nearest degree. Reflected image. I think that's a typo. There is no reflected image here. There's a translated image, but there's no reflected image. So I think that's just a typo, you guys. But remember, they all will be the same. So I'll tell you what, let me scooch out of this, get back to my original, so it's not just so worrisome. Make that a little bit bigger so you guys can see, and I'll find the angle measure. Remember, finding angle measures in GeoGebra, you got to go in a clockwise motion. So it's like angle B is 90. BCD, so C is 63.43. CDA, so D is 153.43. And then DAB, so 53.13. Let me move this so you guys can see a little bit better. All right. Again, I think that's a typo. There is no reflected image. They are just translated. One was horizontally to the right 5, and one was vertically down 8. There is no reflection here, so I think that's just a typo. But I'll tell you right now, the angle measures are not going to change, you guys. They're going to remain the same. So let's see. Angle B. Again, the letter in the middle is the vertex. So B was 90. So it's going to be 90 across the board, even though the figures aren't there. Just going to keep that in mind. Angle C. What they want that to the nearest degree, right? Yeah. So angle C to the nearest degree is 63. So 63, 63, 63. D is the letter in the middle. That's the vertex. 153. So 153, 153, 153. A is the letter in the middle. So A is the vertex, be 53. Again, forget the typo, you guys. I'm not sure what they meant by reflected image. There was no reflected image. There was a translated image, but no reflected image. All right, question 6. All right, how do they measure the angles of polygon ABC to compare to the translated? Well, they're going to be the same. I've already said that. Based on your observation, what can you conclude about preservation of angle measurements during a translation? They stay the same. The angles remained the same, and they stay the same under a translation. Oops. All right, question 7. Now measure the lengths of the sides. They're going to stay the same. All right, that's fine. Let's find the length of the sides. So we're going to come up here to angle, distance or length, and click that. Got 3.16. 3.16, 1.41, 3.16. So, wow, 3 of them are the same. 3 of them are the same. One of them is 1.41. Okay. All right, well, no problem. Let's see what I got here. The first one is AB. So, A to B was 3.16. 3.16. Oh. B to C, 3.16. C to D. C to D is 1.41. Oops, sorry about that, 1.41. And A to D was 3.16. Question 8. How do the side lengths of the polygon ABCD compare to those of the translated image? They are the same. What can you say about preservation of measurements of side lengths when the figure is translated? The lengths of the sides did not change and will not change under a translation. The side lengths did not change and will not change under a translation. Only on a dilation, you guys. Only on a dilation does that happen. Can't say it enough. There we go. We are done. Okay, so I think that actually finishes up us for defining rigid transformations. You need to know this one more time. A rotation, a reflection, a translation, those are all rigid motions. You can have a combo of those threes, but you cannot have a dilation. A dilation changes the size and shape of an image. Therefore, it is not a rigid transformation. All right, so I am done with this lesson. Let me know if you have any questions, okay? Email me, message me, whatever you need. I'm here to help. All right, guys. Next lesson coming up.